All right, good afternoon, everyone. It is great to be here. My name is Matthew Flaming. I'm VP of Site Reliability at New Relic.
And I'm Elisa Binette. I lead the reliability awareness and reliability fitness teams at New Relic. Today we're here to talk about SLIs and SLOs in the real world. And the idea that SLIs and SLOs are a critical part of a mature reliability practice probably isn't news to anybody here. But when you're thinking about a modern, complex software architecture, it can be really hard to figure out how to implement SLIs and SLOs, but both what you should be measuring and how to measure it. So today we're going to share some concrete, practical examples of how you can define SLIs and SLOs in the context of a modern software architecture. And we believe that these are useful templates that you'll be able to take home and apply within your own environment. Now, one quick disclaimer, we both work at New Relic, and since we drink our own champagne, that means we monitor our platform with New Relic. So some of the screenshots you see will be of New Relic. That's just the example that we're using here today. We believe that the concepts that we're talking about apply fairly universally, regardless of the tools that you're using.
And I guess one more quick disclaimer. If you attended the SLIs and SLOs workshop that Liz, Christina, and the other folks from Google were putting on this morning, some of this will be a little bit less novel, but we think this will be an interesting elaboration of some of those concepts across a broader platform.
Good point. All right, so we all love acronyms, but just a quick check to make sure we're using all of these terms the same way. An SLI is a key measurement of availability. SLO is the goal for how much availability you want out of your system. And then the SLA is the legal part of the contract. What happens if you're not actually meeting your service level objective? And we're going to talk about SLIs and SLOs today, but we're going to focus primarily on SLIs because until you have a place to begin measuring, you can't measure your SLOs without SLIs.
OK, so just as an example, our SLI, SLO, and SLA for this talk might be
10 key takeaways in less than 30 minutes, 99.9% of the time.
Or we'll buy the conference organizers a drink.
Sounds totally fair.
Sounds totally fair.
OK.
All right. So again, in this talk, we're going to be using a very simplified example of the New Relic platform. And when we look at this platform as a whole, we might say the system is available if we're collecting customers' data and if our customers can log in and view that data. And in the case of just this example, we're going to be shooting for 3 nines of availability, 99.9% uptime. So, OK, great. We've got our top-level definitions of our SLI and our SLO. It's time to start diving in and implementing points of measurement in the system so we can understand where our hotspots might be and how we're doing against our goals. But the thing is, when we look under the covers of a modern platform like this, there is a lot of complexity, right? There are service nodes, there are DBs, there are message buses, there are load balancers. It can be a little bit daunting. So where do we start? Well, to answer that question, we need to introduce one more piece of terminology, which is the idea of a system boundary. So the system boundary is a point where one or more components expose one or more capabilities to external customers. And those customers can be either other systems and teams in this environment, or they can be external customers. So now, using this idea of a system boundary, we can group together the components of this platform into logical units. We have some components that make up a UI tier, some services like our login service, some data tier components, an ingest component. And of course, there's one more boundary, which is the system boundary between this platform as a whole and the external customers, the end users. And at most organizations, including at New Relic, team boundaries tend to line up pretty well with system boundaries, which makes it a little bit easier to draw this kind of a map. And we're going to focus on defining SLIs and SLOs at these system boundaries, because those boundary SLIs and SLOs are the most highly leveraged. That is, they're useful to the most people. So, as an engineer maintaining a particular system, I might care a lot about the performance of my individual databases.
Definitely.
But if I'm a customer of that system, I really don't care how often the underlying databases failed over, as long as the system as a whole remains available. What I care about is things like how much caching and retry logic and resilience do I need to build around this dependency. And that's the information that the boundary SLI and SLO gives me. And that same information is the most useful to the organization as a whole as we're making decisions about things like trade-offs between developing new features and investing in reliability. So again, we're going to focus on these boundary condition SLIs and SLOs. And writ large here, we're really going to be following the same recipe when we look at all the different pieces of this platform. What we're going to do is, first, we're going to start off, as I said, by identifying those system boundaries. Then we're going to articulate the capabilities that exist at each system boundary. And for each of those capabilities, we're going to start by just coming up with a natural language definition of what it means for this thing to be available. And only after we've come up with that natural language definition of what we want out of this thing, what available means, then we're going to start diving into the technical underpinnings and defining one or more SLIs that correspond to that definition of availability. After we've defined those SLIs, we're going to start measuring them so that we can establish a baseline of performance. And after we've established the baseline, we'll establish an SLO target. And then finally, we're going to iterate because, hey, we all like iteration. Sound good?
Excellent. Sounds like a great recipe.
All right, let's dive in.
So now that we have the system boundaries defined, let's start digging in a little bit. So looking back to our original definition of availability for our overall platform, one of the key things we need to be able to do is collect customer data. So that'll be one of the things that we measure when we're talking about availability of our ingest tier. Now, what this tier does is collects customer data, and then it routes it to the correct place for other systems to consume. So you can see that this actually offers two distinct capabilities, ingest and routing. So we'll have at least one SLI for each of these capabilities. Now, for data ingest, we might want to say something like X% of well-formed payloads are accepted. And so we could calculate this by figuring out how many payloads return a 200 response. Since this is a non-transactional asynchronous system, we don't really care about response time. For data routing, on the other hand, we do care about latency. And so we can measure this by comparing the ingest timestamp for each of the messages to the time each of those messages were available on the message bus. Now, we do have SLOs for each of these things, but we worry a lot less about the service level indicators SLO, the acceptable latency in this case, than we do about the service level indicator itself, because SLOs are fairly easy to adjust down the road. And in fact, there might be business reasons for adjusting SLOs. For example, if you have a less mature system, you might start with a less aggressive SLO and then increase it over time as your system matures.
Keep raising the bar, yeah.
Yeah. All right, so if you have sharp eyes, you might have noticed that there were no traffic or workload thresholds on that previous slide, which can be really scary if you're an engineer.
Really scary.
But in reality, your workload is a moving target. And if you're lucky, it increases over time. So if you're setting your objectives based on static workload thresholds, you'll just get really frustrated as you have to renegotiate your service level objectives. And there's going to be a lot of frustration by your customers as their expectations get dropped on the floor. Now, we've been talking about the fact that SLOs are fairly easy to adjust over time. That doesn't mean you should just pick any number at random, though.
1 million.
No.
1.
No, we've talked about this. So first you want to define, and then you want to measure before you establish your SLOs. And there's a few things that you should think about when you're establishing those SLOs. Now, the first and most important thing is they need to be based in technical reality. You know, the team has to be able to commit to supporting them. If they don't feel that they are reasonable or they're constantly being missed, it's going to be really terrible for morale. Plus, this is how other teams reason about your system. The next thing to think about is that SLOs represent an organizational commitment and should be used to create organizational alignment. You can't have a major disagreement between your leaders and your engineers about what the SLO should be. SLIs and SLOs represent an ongoing commitment by the organization to invest in the work that's necessary to defend these SLOs over time. Now, there's various ways you can do this. You can manage your workload through API keys and rate limiting, or you can invest in the scaling work that's necessary as your workload increases. We want our engineers to view SLIs and SLOs as a tool that actually allows them to clarify their priorities by surfacing the key scaling and reliability work that they need to do. So again, remember, first you define, and then you measure before you establish your SLO.
Measure first. I feel like I've heard
Yes.
that somewhere. OK. So after data ingest, one of the next key things that happens in the system is data gets stored in one of the main data tier components. And the major data tier component at New Relic is NRDB, our proprietary horizontally scaled database that powers a lot of the platform. Now, going back to that top-level definition of availability, customers can log in and view their data. What that means in this case is, well, the data needs to get stored somewhere, and we've got to be able to query it back out again. So those are really the two capabilities, insert latency and query error rate and response time, that we're going to focus on here. Now, under the hood, NRDB is a super complex system. There are lots of different worker types. There are distributed systems that support NRDB. And under the hood, we're going to care about measuring and potentially alerting on a lot of different conditions, including things like garbage collection time and data durability and event scan per second and all that good stuff. But at the level of the boundary SLI and SLO, again, we can really just look at insert latency and our query responses as proxies for all of those types of underlying behavior. So this is a little bit like what Stefan was talking about earlier in his discussion of canaries. We can look at these simple indicators that are proxies for broad categories of behavior under the hood. So we're going to set an SLI for our query response time. And when we set an SLI for response time, of course, we're not going to look at the average, because averages lie.
Yes, they do.
But we're also not going to look at like the 99.9th percentile, because that's going to be our pathological cases. Instead, we tend to focus somewhere between the 95th and 99th percentiles, because that captures a really broad swath of user experience without pulling us too much toward the outliers. And of course, since we're instrumenting our application, we can slide that percentage around over time if we decide we want to adjust it. And now, here's a kind of neat trick. We're going to configure an alert condition to go off if we violate that 99th percentile SLI. Now, we're not going to use this to wake anyone up. We're going to set a much less sensitive threshold for actually getting someone out of bed. But because we've configured this alert condition, now we can just look at how often this alert went off, how often this is violated, to understand how much of the time the system was satisfying this SLI. And then we're going to do pretty much the same thing for our insert rate SLI. So now we can articulate these SLOs for our customers. We can also express these, instead of two separate items, as one compound SLO. And the advantage of this is it might be easier for customers of the system to reason about this one compound SLO than multiple independent contracts. And if we do this, the trick is we look at how much of the time the system is satisfying all of its SLIs. In other words, we logically AND them together in order to get this compound expression of what to expect out of the system.
Nice. All right, so in addition to our horizontally scaled data tiers, we still have hard-sharded legacy systems.
Tragically, yes.
Yes. So we're trying to get rid of things like these. However, they still exist in our production platform, so we still need to have SLIs and SLOs to measure these.
Tragically, yes.
Yes. So in a lot of respects, it's very similar to how we measured SLIs and SLOs for our newer data tier. Conceptually, it's about the same. The specifics are a little bit different. And so in this case, what we need to do is set an SLI and SLO for each of the shards. And that's because due to the hard sharding, your workload is not spread across the shards. Now, this is an important distinction between horizontally scaled and hard-sharded systems. In a horizontally scaled system, if you lose 1 out of 3 nodes, then statistically that's a 33% error rate, and you can assume that 2/3 of all of your users' requests are still being handled as expected. So we measure the SLI and SLO as inclusive of all of the nodes. In a hard-sharded system, however, if you lose 1 out of 3 nodes, then yes, statistically it's still 33%, but in reality what's happening is a third of your customers are seeing 100% error rate, and 2/3 of your customers think everything's just fine.
Statistics.
Yeah, that's a really big difference, a third of your customers being down and all of your customers being partially degraded. So we're going to measure SLIs and SLOs by the logical instance, and in this case, each shard. And we would also apply this same methodology for a cellular architecture or a multi-region architecture where each logical instance has different failure domains.
So one SLO per failure domain.
Exactly.
Got it. All right. So we've now talked about defining SLIs and SLOs for a bunch of different components in this platform. But we haven't yet talked about SLIs and SLOs for some of the most important pieces of the platform, specifically our networking tier and our container scheduler and runtime cluster. And these, it turns out, are super important because these are going to be the foundation of everything else.
Just a little.
Right. And these also can be some of the hardest places to reason about how to define SLIs and SLOs because, right, like the network, it's like the force, right? It surrounds us, it binds us, it's everywhere.
We want it to always be with us.
Right, so how do we break it down and think about this in terms of an expressible SLI and SLO?
Great question. So looking back to the beginning, we talked about a simple recipe. So the challenge here is to break down, in this example, the networking tier into specific, well-defined capabilities. And funny enough, there's one weird trick you can use when you're unsure about what your capabilities are.
What's that, Elisa?
Talk to people. Yeah. So talk to other engineering teams and ask them how they use your system. Ask them what they're using it for, what guarantees they expect. And from this, you can recognize common patterns, and it will help you define what your specific capabilities should be. Now, in the example of the networking tier, we have 3 distinct capabilities. We want load-balanced endpoints that expose our services internally or externally. We want connectivity between racks within an AZ. And we want connectivity between the AZs. Simple. So we'll have an SLI, SLO for each of these capabilities. Now, although we can adjust SLOs down the road, when you're talking about something like the network tier, you really need a higher SLO because it's a really hard dependency for all of the services running on it. It turns out it's pretty hard to code around a network failure. And in fact, you can expect to lose roughly an order of magnitude for each tier of your infrastructure. So setting an SLO of 99.99 4 nines for the network tier is a fairly reasonable place to start if you want 3 nines, 99.9% availability for the services that are running on your network.
Super true. So it's actually worth pausing, I think, a second to dig into this a little bit more and how we think about SLOs for different pieces of our infrastructure. So looking at this platform, we have a stack of dependencies. At the bottom, we have the network. Everything needs the network to run. Then we have our ingest tier, which, unlike the network, is pretty fault isolated. Everything except for the network can go down, and ingest will keep running. And similarly, ingest can go down, and everything else will stay up. On top of that, we have our data tier. And the data tier is actually a dependency for quite a lot, the service tier and the UI tier. And the UI tier is at the top of our dependency tree here. Nothing else depends on the UI, except it turns out for our customers, which are really the most important thing.
Yeah, details.
OK, so let's look at a few different failure scenarios. So if we have a failure in the UI, well, that's going to be an isolated failure. It's not going to impact any of the other tiers. And isolated failures tend to be the fastest to address and recover from. So far, so good. If we have a failure in the service tier, well, that's going to take down the UI tier. But this is a case where we can probably implement some graceful degradation strategies. We can do things like caching on the UI tier or exposing just partial functionality to customers. So this is a failure we can mitigate to some extent. If the data tier goes down, yeah, that's going to be a lot more serious. We're going to take down our service tier and our UI tier. It may be harder to degrade gracefully, but still perhaps possible. If our network tier goes down, that is the worst case scenario for us. So number 1, everything else is going to go down. But number 2, we're likely to see propagation of mean time to recovery. So if I have a system and my dependencies go down, my system is probably not going to come back online the instant my dependencies recover. There's going to be a little bit of lag there. So mean time to recovery tends to increase with each tier of services impacted. And it also tends to be much harder, as Elisa mentioned, to code around failures in the infrastructure tier, to degrade gracefully. If I have a region that goes down, or an AZ that goes down, unless I have done a lot of preparation, I am probably not going to be able to handle that in a graceful fashion, but I'm going to be hard down for my users. So investing in those higher SLOs and that greater reliability in the infrastructure tier really is one of the best things I can do for the health of my platform overall.
Definitely. So the next core piece of infrastructure that we need to talk about is our container, scheduler, and cluster. And next to the network, this is also our most critical part of our platform because it's where all of our services actually run. Now, basically, what we expect out of this is the ability to run jobs on demand, in this case, Docker containers, with the computing resources required that they're requesting. So there we go. In a case like this, this is where we might need to get a little bit creative about how we define the SLIs along with the natural language capabilities that we have. Now, the first criteria that we want out of this system is that we want jobs that actually get the resources that they expect. And in this runtime cluster, we're actually using hard quotas and process isolation for our memory and CPU. So this sort of resource starvation should never actually occur.
The job just won't start.
Yeah,
right?
they just won't start if there's not enough memory or CPU for them. With network I/O, on the other hand, it isn't formally isolated. So this is something that we need to measure. And since we don't have really great metrics on per I/O job weight, one of the things we can do is measure the network traffic, network throughput on a particular host, and then assume once we've reached a 90% link speed that the link is saturated, and so the jobs aren't getting the full availability on that host. So we can subtract that time, the amount of time the link is saturated, from the total availability for that particular given host. And this is an example of an indirect measurement, but one that's pretty critical in our understanding of the actual capability that we're looking for in this system.
Totally true. So in addition to the resources that a job requests being available, part of the definition of availability here is that the job can run. But again, this is going to be a little bit tricky for us to reason about because we're not actually interested in the uptime of a job itself. If a job fails, it's likely to be because of the code within that job, doing something unexpected. Instead, what we're actually interested in is the potential uptime available to a job. And in order to measure this, we're going to need to get a little bit under the hood. So in this case, we're using Mesos and Marathon as our compute fabric. Don't ask why. Mesos and Marathon use the concept of tasks to express jobs. And we can see there are a bunch of different states that a task can be in. There are a couple of states here that represent a task that's been scheduled but not yet started on the cluster. And then another collection of states that represent error conditions in the cluster itself. So we could theoretically look at the job status and subtract the amount of time that tasks spend in one of these states from the availability. We can say if a task is in one of these states, that's probably downtime introduced by the container fabric itself rather than by code within the job. Now, this is actually going to be a little bit of work to build a service to pull these stats out of the API and do this computation. So as a first order approximation, what we might do is just build a synthetic script that launches a simple job over and over again and measures startup time. And although it'll be a little bit less exact, it still gives us good general visibility into this behavior. And having an approximate sense of our SLI and SLO performance is a lot better than having no sense at all.
Definitely. All right, so moving up our stack, the next SLI-SLO combination that we need to talk about is for our UI tier. Now, at this point, the capability that we expect is fairly straightforward. We want an experience that's fast and error-free. But when you're what you're going to need to do is change your perspective a little bit, because up until now, we've been measuring things that are going on like in our server. We actually want to look at the customer experience, what they're actually experiencing within the front end. And that means we're going to have to pay attention to what's going on within the browser. So one of the things we can measure is page load time. And similar to server response time, we'll probably want to look at something between the 95th and the 99th percentile, rather than the average. You might also want to set an SLI for different geographies. You may also want to think about, since this is a modern web app, it's not just page load time that matters. This is a single page web app, so you might want to look at things like the interactions that are happening in the browser, like AJAX actions and DOM changes. And of course, you're probably going to want to pay attention to your server errors and your JavaScript errors. You might prioritize UX correctness for some browsers more than others. Lots of things to think about. Now at New Relic, we use New Relic browser monitoring to collect the data about response time for different geographies, and as well as browser interactions for user agents. But the key thing that I wanted to mention here is that when you're talking about a modern web app, simple ping is not enough. It's not a good representation of your end user experience. And ultimately, what you care about is your user experience.
Turns out that's again what matters most, right?
Yeah, they're paying us. All right, so one other thing. So we still have one more thing to think about. Now, we've defined SLIs and SLOs for each of our service capabilities that define our overall platform. But we still want to measure our overall correctness and making sure that everything is actually working together. So a sanity check, so to speak. Like right now, we know what's going on within all of the different components, but not if it's working all together as expected. So keep in mind, for the UI, we were actually just measuring browser error-free responsiveness. We weren't actually doing the end-to-end check. So what you can do here is set up a simple synthetic script that mimics a workflow, sends a piece of data to the system, logs in, checks to make sure the data you expect is available. And if you see a significant discrepancy between the performance of this script and the overall performance of your SLOs for the components within your systems, then that means you need to revisit your SLI methodology. So now that we have talked about the sanity check, and we're talking about the customer experience, there's one more thing that you should actually think about. And that's the fact that all of the SLIs and SLOs that we've talked about so far have been representing the average customer experience. And we know averages aren't telling us the whole thing. So a purely statistical view can actually hide the fact that some of your users may be having a far better or far worse experience based on their particular usage profile. It's also a reality that the business might say, we want to offer great availability for all of our customers, but we want to offer really great availability for some of our key business strategic partners. So what you can do is set up specific customer SLIs and SLOs. Now, this can be fairly straightforward. You can use your existing monitoring data. If you're tagging your analytics events, you can query it for a specific customer ID. Or you can also set up another synthetic script, which makes sure that you're receiving data from that key customer and that you're able to query it back out of the system. And in fact, having a few customer-specific SLIs and SLOs can actually be a good thing because, once again, experiences vary based on usage profile. However, you do want to make sure that you don't set too many customer-specific SLIs and SLOs because it introduces noise into the signal that your engineering teams are using to make reliability decisions.
Again, keep it simple.
Keep it simple.
All right, shall we recap?
Sounds great. Let's do it.
All right.
All right. So worry more about SLIs than SLOs.
Start with that natural language description of what it means for something to be available, not the technical underpinnings.
All right. Define SLIs and SLOs for specific capabilities at your system boundaries.
So remember that each logical instance of a system, like each hard shard, should get its own SLO.
SLIs are not the same as alerts. Do not page on them. They're not a replacement for thorough alerting.
Yes. You can logically AND together SLIs for a given capability to generate a single SLO for the capability that might be easier for folks to understand.
And write down your SLI and SLO contracts and share them.
Don't keep them secret.
They are not secret.
All right. Remember, your key customers might need their own SLIs and SLOs in moderation.
Right. Assume your SLOs and SLIs will evolve over time.
And even though they're going to evolve, remember that they represent an ongoing commitment.
All right, so did we meet our SLO for this talk?
Oh, just barely.
Oh,
13
yeah, we
seconds
did.
to go.
20
All right, well, we'd still love to buy the conference organizers a drink. Come up and see us. Thank you so much. It's been a pleasure. And do we have time for questions?
You have 10 minutes.
Oh,
my
yay.
gosh. Wow.
Thank you.
Hey, hello. Thank you for a great show, let's say. I'm specifically interested in defining SLI for network because networks were designed to be like super reliable, 5 nines or more, or so on. Now we have a couple of tools to collect time series data, but it looks like we don't have clear exporters for network equipment, especially if you run your own on-premise data centers. Can you share something more like how to define that we didn't met or SLI for network, or how to define that something went wrong?
So the network SLIs and SLOs really are some of the most challenging ones. And the right solution is going to vary quite a bit depending on what type of infrastructure you're running. For on-prem situations, smoke ping is a pretty good tool that gives you a good sense of latency between multiple targets. You can also generate something like this synthetically by running services on distinct hosts and targets within different racks or availability zones, and just doing round-trip pings between those discrete and non-moving targets. For load-balanced endpoints, which are often the thing where there's the least redundancy that we care about most, typically, that involves harvesting data out of whatever load balancer you're using. So most load balancing technologies have some form of API. And you can also, again, do this statistically by making requests through this to make sure that there is connectivity to the system. Thank you. There's over there.
Hi, quick question on defining SLIs and specifically the SLOs, not so much SLIs, sorry, on services that or dependencies and across the stacks. So you set a target. Do you just consider on what you are willing to offer? And when you consider, or do you also consider your dependencies and what they offer you? So do you do this incrementally, or just, no, this is what I want to offer, and if my dependencies don't offer me this, then I'll just have to go and shop somewhere else?
So there are really two fairly distinct models for thinking about SLIs and SLOs. One of them is essentially around owned incidents, which is to say, if I subtract away all of the downtime of my dependencies, what was the pure uptime offered by my system? The other is outcome-oriented SLIs, where you say, OK, including the downtime introduced by all of my components, what outcomes were I delivering for my customers? And that latter tends to be more useful and more meaningful because ultimately it's what people are experiencing. It also tends to incentivize better behavior in that it means, OK, I need to build systems that are as resilient as I can make them against dependency failures. So it tends to be something of a negotiation and something of a moving target. Usually, product management tends to get involved. And you say, OK, well, here is the SLI that I can offer given the state of my dependencies right now. And if there's an issue, that can incentivize more investment in shoring up the reliability of things lower in the stack. So it is an iterative process. And if you're going with the outcome-oriented SLIs, which again, generally are more meaningful in terms of capturing what you're actually delivering, you do need to factor in dependency failures. and then have a conversation about, all right, well, given the state of my dependencies, here's what I can actually offer.
The alternative, too, because if you have autonomous teams, they want to know what's within their control. So yes, there's resiliency work, but there's also just stuff that they don't have control over. So you can get buy-in for everybody to have higher SLOs because math works that way. So if everybody's willing to sign up for a more stringent SLO, then you don't have to build as strong a dependency chain.
What do you do when you're strongly exceeding an SLO and then move back towards the level that it's actually set at?
I'm not quite sure if I got the question. Can you repeat that, please?
Let's say that your latency SLO is at the 95th percentile, and you're meeting it at the 99th percentile, and then your performance degrades back.
So there are a few different ways of dealing with this culture, and this becomes really a cultural conversation. Normally we would say, all right, if you are not meeting your SLO, then your focus needs to shift away from new feature velocity towards reliability in one way or another. And that can take different forms. So in some organizations, it is you can't do releases unless they are related to addressing the SLO concerns for some period of time until, for example, the trailing 30-day average meets the levels that you're expecting. But looking over some time period and saying, OK, over a given time period, you will periodically dip below your SLO for brief periods of time. That's normal, right? There are these fluctuations. So you don't want to look necessarily at SLOs in 5-minute increments or 1-day increments, but cumulatively over a period of at least days, if not a month or so.
But if we're exceeding our SLOs and we actually degrade our service and we're still meeting them. I mean, we publish them, we talk about them, so we don't want our teams to be dependent on a level of service that we're not actually promising. But we don't break stuff, unlike some places.
Right, and I think this is the practice I've heard about at some organizations that they'll deliberately degrade their service so that dependencies are really responding to the SLO commitment rather than the higher delivered performance. So, for example, there's a tendency with the network to think about the network as this infinite and infallible resource. Well, in order to get around that, it can be useful once in a while to say, OK, we're going to blip the network so that people actually factor that behavior of production into their reality of how they design systems.